Good day, everyone. I am Alvin Bohol, and today I am going to discuss to you one of the topics in computer programming, and that is handling primitive data types. So, at the end of this lesson, we will be able to differentiate variables from data types and identify the classifications of variables, identify the classifications of data types, identify the different data types available in C++, and argue the practical data type to use. Now let's start our lesson. So data handling refers to the process involved in managing, storing, processing, and analyzing data. So this is similar as handling where we store and retrieve something. In computers, the data is stored and retrieved in the RAM. Okay, so because of programming languages, data handling becomes possible through variables. Now let us discuss what is handling variables. So handling variables is like handling a real boxes. Okay, for example, in this comparison. Okay, so in a real world, we take a box, but in programming, we declare a variable. Okay, and in a real world, we place variables in the box. Then in programming, we assign values to the variable. Okay, then if in real world we take variables out of the box. In programming, we retrieve the variable's value. Okay. However, there is a slight difference when we talk variables out of the box in a real world between the computer programming, because when we take variables out of the box in a real world, when we take them permanently. Okay, so we do not have that value anymore within the box after taking them out. However, in computer programming, when we retrieve the variable's value, the value is still within the variable, because what we take out of the variable is just a copy of the value. Okay. Now let us proceed with our next term which is a variable. Okay, so what is variable? So in programming languages, when talking about variables, we have the so-called explicit, the implicit, and anonymous variable. Okay, so when we say explicit variable, these are variables that we declare usually at the start of our application before any processing is done with them. So for example, this one, int age is equals to 25. Here, we are declaring an integer age and assigning the value of age as 25. So this is an example of an explicit data. Okay, we usually start our application before any processing is done within, and we declare a variable. So another example is the string name. We declare the variable name and assigning it the value of John. Okay, so remember that in explicit data, we are declaring the variable. And however, in the implicit data, so these are variables that are used right away without the need of declaring it. So they are referenced using a name, meaning to say they are made in such a way that they are only allocated some memory when called. So they are usable within the context where they are only initially used. And next is we have the implicit. I mean the anonymous variable. So anonymous variable is like implicit variable. They don't need, so the variables that are used right away without the need of declaring them. However, anonymous variable are not referenced using a name, unlike with the implicit variable that they are referenced using a name. Okay, so this means that anonymous variables that In anonymous variable, the computer itself know how to call them. So only the computers know when to call them in a program. Then typically, when they are declared and destroyed after use. Then anonymous variables are used, mostly they are used during the computation. Okay, now to better understand with this, we need let us try to understand are the data types. Okay, so when we say data types, these are the restrictions we place to variables that limit them to handle only our specified type of data. So in data types, we have two classifications. Okay, first is classification by value and classification by construct. So classification by value means that when data types are classified by value, we have the explicit and implicit data types. Okay, so explicit data types, these are data types that are declared and defined. Okay, for example, we declared a string variable, therefore we can only store string values to that variable. Another is when we declare an integer variable, therefore we can only store integer values to that variable. Moreover, explicit data are often called strong type in some other contexts. This is mainly because of how the values to be stored are treated. In addition, in addition, being called strong type suggests that there exists a bound between the data types. So by extension, including the variables and the value stored. Now for the implicit data type, so they are taken depending on how they are stored and used. So they are not defined, which often causes ambiguity on how the values are to be handled. Then implicit data types are often called variant type because for example, they are especially used in web development wherein the values like those which come from the users are initially treated like strings before they are converted to what they are actually. Okay, so that is the difference between the data types explicit and the data types implicit and the classification by value. Okay, so now let us discuss the second classification by construct. So, so data type can also be classified by construct. Okay, by construct in programming means how they are constructed. It also means by what they are composed of. So in other words, by construct, this one means or refers to the fundamental building block that and mechanisms that define how something is put together in programming. Okay, so by construct means how something is put together in programming. Okay, now there are types of classifications by contrast, and we have the primitive data type and the reference data type. Okay, so what is primitive data type? So primitive data types are data types of singularity by nature, meaning to say they contain only the values they are supposed to contain. So they do not have any other components like properties and internal functions. For example, primitive data types are like folders for paper. So that folder only contain the values they are supposed to contain, and that is for papers only. So meaning to say that folder only contains paper and nothing else like clips, pins, etc. But only paper. So that is what primitive data types. Now opposite with the primitive data types is we have the reference data types. So reference data types are data types that are objective by nature. Okay, so they do not only contain the values they are supposed to contain, but also have other components like properties and functions. So unlike primitive data type, reference data type contains variables within them. Okay, so for example, for a folder. So in primitive data type, that folder is only for the paper. However, in the reference type or data type, that folder is not only for the papers, but it can also include the pencil, the pen, eraser clips, and many more. So whatever you want to put inside that folder. So that is what reference data type. Okay, or a great example of a reference data type. Now, in C++, these data types are classifiable in integers, floating points, booleans, and characters. So this is and characters. Here, this classification is based on what specific values are allowable. Okay, so here we have the integers, the floating points, and the booleans, and these values are numerical in value. Okay, whereas this character are are textual values. Now let us discuss integers first. Okay, so when we say integers, these are values that are numerical in value and they do not have any decimal precision. Okay, remember that integers are values that do not have decimal precision. For example, counting numbers including zero. Okay, so this is an example of an integers all counting numbers including zero. Now, integers have data types also, so such as the regular integer, the long integer, and the short data types. Okay, now let us examine this table of an integer data types. Okay, this table 1 shows about the signed, this one, integers value boundaries. Okay, table 1, this is assigned. It also shows the minimum, this one, and the maximum value of integers based on the data type. So in a regular integer, its identifier is signed, then its minimum value is this one, and its maximum value is this one. So the same with the short integer and long integer, they have minimum value and maximum, also in the long integer, long minimum value and the maximum value. Okay. Another is one. Okay, so now for this table 2, it shows about the unsigned integers value boundaries. So the first one table is about the signed integers value boundaries, and here this is unsigned integers value boundaries. Okay, we also have data type, the regular integer, the short integer, and the long integer, and also it has the minimum value and a maximum value. Now, what are the roles of these identifiers? So as we can see in the tables, the table 1 has assigned identifiers, and table 2 has a unsigned identifiers. Well, in C++, signed and unsigned identifiers are used to specify the range of values that a variable can hold. Okay? So for example, if we use the short integer data type with unsigned short. Okay, unsigned identifier. So its minimum should be 0 and its maximum should be 65,535. Now, what do you think will happen if we forget to use the identifiers in our program? So, for example, we just input the value, but we forget to include the identifiers such as the signed and unsigned. Well, okay. So, well, if we do not set, or let us say we forget to set any of the two identifiers, the signed and unsigned, C++ will interpret it as signed identifier and will use its signed value. So as default, C++ will use the signed identifier, okay? But what if we, let us say, we exceed the set boundaries of the integer's value? Okay, so if the set boundaries for the integer values exceed its limit, a so-called overflow will happen, which resulted to unexpected outcome, which typically result for the application to terminate. So when the integer's value exceeds its limit, so the program will not continue or it will result an error such as the application will be terminated. So if the value exceeds its limit, then the program or the application will be terminated. Now, let us discuss the primitive data types floating points. So what is floating points? So floating points are values that are numerical in nature. Okay, remember that floating points are numerical in nature, but they contain decimal precisions. Okay, so floating points is same. They are same as integers, which values are numerical in nature. However, floating points use decimal precisions, while the integers do not contain or do not use decimal precisions. Okay? For example, of a floating points, numbers with decimal points such as 0.5, 0.75, and many more. Okay? Now, here is a table of our floating point. So we have data type float, the double. We also have an identifier float double. We also have the minimum value and maximum value. Now, these data types in floating points are used to represent real numbers with decimal points. However, they differ in their precision and range. As you can see in the table, sample this one. This one, the float. Okay? The float has a lower precision, meaning it can represent numbers with fewer decimal places. While the double, this one, as you can see, double has a higher precision, allowing it to represent numbers with more decimal places. Okay? Also, float has a smaller range of, as you can see, meaning it can represent numbers within a narrower range of values. However, the double has a larger range, so it allows it to represent numbers within a wider range of values. Okay, so that is the difference between these two. Okay, so data is the float variable and the double data type. Now let us discuss the booleans, our last primitive data type. Okay, so booleans values are values classifiable to either a true or false. So they are also numerical in nature as C++ stores them as zero and non-zero internally. Okay, so true values for Booleans are considered as non-zero positive integer, while false value for Booleans are considered as zero. Meaning to say, if the value is one or a non-zero positive, so that it means that that value is true. And if the value is zero, then it is false. Now for the last, we have the characters. So characters are the only primitive data types that is textual in nature. So regular characters can only present one characters per variable, and strings can be represented as a series of characters. Oh. So that is why in computer or that is why in programming languages such as C++, a string is declared as an array, this one, as an array of characters, and characters use this this char identifier, whereas the string use char variable, okay, array syntax. Okay, now let us proceed with our next, which is the data types and action. Okay, so now that we know all the supported primitive data types in C++, so for an important reason, we need to discern the importance of having those data types and when we will generally use them in a real world application. Okay, so now let us talk with the data structure. So in data structuring, it is very important to know how the computer in general, such as its OS or the operating system and the CPU in particular, which handles variable. This is because when we declare a variables, the computer allocates a specific empty and unused region in the RAM where we're gonna store the supported value. Next is remember that all that computers essentially only understands binary, a series of zeros and ones. So if we take unsigned short integers, for example, like this one, the maximum value allowable for them is 65,535. So referring to the table that we have discussed earlier. Okay. And it's binary, and in binary it has 16 ones. So we have 16 ones. So hence the computer will allocate 16 sectors if we declare one unsigned short integers. Okay, so the same thing with the signed short integers. So which has the value of 32,767. So we will have its binary, this one. Okay, so this is data structuring. Now, a character data type occupy 8 bits. So the value differs in how the compiler sets the value of the character. So for example, this one. So computer A can store the character A as this one, while the compiler B can store character as this one. So this means that the value differs on how the compiler sets the value of the character. Okay. Then we have the Booleans. The Boolean's data type occupy only one bit, either 0 or 1. So for true, it is 1, and for false, it is 0. In Boolean expressions, a zero-valued integers means false, while a positive integer is interpreted as true. Okay? Then, let us discuss the real-world application. So, now that we understand how data types work technically and theoretically, we need to discern the most applicable data types per scenario. Okay, since there are unlimited numbers of possible scenarios, we will only tackle the most common and general of them. Okay, so first is when we hand when we handle any numeric values, we know to choose only integers and floating points. Okay, so what determines which of the two will be used relies on the need to store the decimal values. So for example, we use integers if we want to count specific numbers of objects. Okay, remember that integers okay, don't contain a decimal precision. So example number of cars. So I guess there is no one half car, right? So if we want to count a specific number of objects, we use integers. However, if we want to measure something like a body mass index, the temperature or height, example body mass index 24.9, so we use the floating points. So because floating points is containing the decimal precision. Okay? However, if we only need to check the parity of an object or state, okay? So for example, this one, the gender, the color, or nationality, we use Boolean. Okay? We use Boolean if we want to check the parity of the object. Therefore, our decision is dependent on the maximum number we want to anticipate its values could become. So, because incorrect usage of these data types will cause not only to fail our application, but also to affect our entire system. Okay? So now, before we end our discussion, let us summarize first what we have learned. So from the discussion, we have learned the different variables from data types and the classification of variables such as the explicit variables, the implicit variables, and anonymous variables. That when we say explicit variables, these are variables that we declare. Okay, so usually at the start of our application before any processing is done with it. Then when we say implicit variable, these are variables that are used right away without the need of declaring. The same with anonymous variable, they don't need any declaring process. Okay. Also, we are able to identify the classifications of data, such as the data type by value and by the construct. That classification by value have two data types, which are the explicit and implicit data types. That when we say explicit data types, these are data types that are declared and defined. Okay, they are declared and defined, while the implicit data type, these are data types that are taken depending on how they are stored and used. And in the classification by construct, we have two data types also, which are the primitive data type and the reference data type. Okay, and when we say primitive data types, these are data types of singularity by nature. So opposite with primitive data type, reference data type are data types that are objective by nature. Okay, so moreover, we are able to understand the different data types in C++, which are the integers, the floating points, booleans, and characters. So when we say integers, these are values that are numerical in nature and they do not have decimal precisions. While when we say floating points, this is the same as integers, which values are numerical in nature. However, floating points use decimal precisions. Then for the Boolean values, these are values classifiable for either a true or false, and they are also numerical in nature as C++ stores them as 0 and non-zero internally. Lastly, we lastly we have the characters. So these are the only primitive type that is textual in nature. Also, upon learning the entire lesson, we are able to argue the practical data type to use. When we handle that when we handle any numeric any numeric values, we need to choose only between the integers and floating points. Okay, so if the so we use integers if we want to count specific numbers of objects, and we use floating points if we want to measure something like body mass, temperature, or height. However, if we only need to check the parity of the object or state, we only need to use the Boolean. Okay, and here ends our discussion, and I hope you learned something. Thank you for listening.